Okay, so Nvidia just dropped a model that can listen to your voice, transcribe it, translate it, and still write code and reason like a regular chat model. And it's only 2 billion parameters. That's small enough that we're going to run this thing on a completely free Google Colab notebook today. No fancy GPU, no cloud bill, nothing. And by the end, we'll even have it running in a clean web interface you can talk to with your microphone. It's called Nemotron Audex 2B. And honestly, for a model this size, some of the stuff it pulls off is a little ridiculous. Let me show you. Nemotron Audex 2B is what's called a unified audio text model. And that word unified is doing a lot of heavy lifting here. See, normally, if you want an AI pipeline that handles voice, you're duct taping 3 different models together. One model to turn speech into text, a language model in the middle to actually think, and a third model to turn text back into speech. 3 models, 3 sets of bugs, 3 things to babysit. Audex says, nah, one model does all of it. Speech recognition, speech translation, generating speech, even generating sound effects from a text description, all in a single 2 billion parameter package. And here's the part that got my attention. Nvidia's whole pitch, it's literally in the title of their technical report, is unified audio intelligence without regressing on text intelligence. So it keeps its reasoning, its coding, its general knowledge, and it supports a context window up to 128,000 tokens on a 2 billion model. That's wild. All right, quick architecture breakdown, and I promise to keep this painless. At the core, there's a regular text language model. That's the part that thinks. Then Nvidia bolted on 2 things. On the way in, there's an audio encoder. It's actually a whisper-based encoder, which you'll literally see in the files when we download this thing. Its job is taking raw sound and converting it into embeddings the language model can read, right alongside normal text. So to the model, your audio basically just looks like more words in the sentence. On the way out, they expanded the model's vocabulary to include audio tokens, little discrete chunks that represent sound, with separate decoders that turn those tokens back into an actual waveform. So, encoder is the ears, the LLM is the brain, and the decoders are the mouth. One model, full loop. One more cool detail, it has 2 modes. A thinking mode, where it reasons step by step before answering, and an instruct mode where it just answers fast. You can flip between them, and we'll use both today. Alright, enough theory. Let's build this cell by cell, and I'll explain what each one does. First, the one setting that matters. Go to Runtime, change runtime type, and pick the T4 GPU. That's the free one. Cell 1 is just a sanity check, Nvidia-SMI, and you should see a Tesla T4 with about 15 gigs of video memory. This model only needs around 6, so we've got plenty of headroom. Cell 2, installs. We're grabbing an up-to-date Transformers library, Accelerate, a couple of audio libraries, and, this one's easy to miss, Sentence Piece, because the tokenizer needs it. Downloads the entire model repo from Hugging Face. And heads up, it's a big one, around 12 gigs. So we load the tokenizer and the model from that subfolder. In Float 16. That part matters too, because the free T4 is an older card that doesn't support bfloat 16. 2 things worth knowing here. The audio goes through the Whisper feature extractor first, and the prompt needs special placeholder tokens, one for every chunk of audio. So the model knows exactly where to listen inside the text. The helper handles all that math for us. So from here on, using the model is one line of code. While the model loads, quick favor. I cover a new local AI model pretty much every week, and hitting subscribe genuinely helps this channel keep going. First test, plain old speech recognition. And I figured, if we're testing ears, let's give it a voice everyone on the planet recognizes. So I generated a clip in a very familiar, very smooth narrator voice. Quick note, every voice you'll hear me feed this model today is AI generated. Let me play what I fed it first, so you can judge for yourself.
That's something absolutely amazing could happen.
My prompt is simple. Transcribe the speech in the input audio. Here's what it gave back. Basically dead on. And remember, this is a general-purpose model doing transcription as a side gig, not a dedicated speech-to-text system. Now let's make it harder. Same idea, different voice. This one sounds suspiciously like a certain rocket company CEO, but this time I'm not asking for English text at all. My prompt, translate the speech in this audio into German. So the model has to listen in English and write in a completely different language in one step. And there it is. Straight from audio to German text. No middle step. If you speak German, grade this in the comments. Seriously. Next up, understanding, which is where this model stops being a transcription tool and starts being interesting. For this one, I generated something a little more presidential. Instead of asking for a transcript, I'm asking, summarize this speech in one short paragraph. One thing to notice in the code, I'm setting thinking to true this time. It's a genuinely hard task, so I want the model to reason step by step before it answers. And look at that. It didn't just parrot sentences back. It actually pulled out the argument structure. This is the killer use case to me. Meeting recordings, lectures, podcast episodes. Drop the audio in, ask questions, get answers. No transcription step in between. Last coding demo, speech translation. One cell, a little loop that runs every clip I upload through the same prompt. Identify the language, then translate the speech into English. Spanish.
Desde la playa del silencio hasta los acantilados de Cabo Peñas.
Nailed the language ID, and the translation reads naturally. Spanish speakers. Graded in the comments, you're a better judge than I am. Round 2, German.
Der Dichter fand nicht mehr jene Klarheit des Geistes.
Clean again. Now full honesty, because I don't do hype-only reviews. It's not perfect across every language. The big, widely spoken languages did great in my testing, but some lower resource languages can trip it up. Totally normal for a model this size, but you should know it before you build anything on it. Quick reality check before we wrap. On Nvidia's own evaluations, Audex 2B holds its own against audio models many times its size on audio understanding benchmarks, while staying competitive on speech recognition. One housekeeping note, this model ships under Nvidia's non-commercial license, so it's perfect for learning, research, and personal projects. Just read the license before using it in anything commercial. And here's the deal with the notebook. Everything you saw today, the setup, the fixed folder paths, the helper function, all 3 demos, and the Gradio app, is in one ready-to-run Colab notebook. If you want it, just drop a comment below and I'll share the link with you. That's it. One comment. If you try it, tell me what you threw at it, especially if you test a language I didn't. A like and a subscribe genuinely go a long way. I'll catch you in the next one.